Good morning. Here we are starting week 3. I hope it's going well for you guys. We're now going to talk about triangle congruence. So we have to remember that if two polygons have the same angle measures and side lengths, so same angles and same side lengths for all of the corresponding pairs of angles and sides, then the two polygons are congruent. Okay, and there's a sequence of rigid transformations that maps one polygon onto the other. So that means that if every side is the same and every angle is the same, then the two triangles are congruent. So we have to test everything. So let's see if we can prove that these two triangles are congruent. So do you see how that TR is the same as AG? So T to R is the 90 degrees. So I line up the A with the 90 degrees. TR is congruent to GA. There's one side. So we have this side is congruent to this side. Now I have RI is congruent to AN. Okay. These sides are congruent. Now I have to figure out what this third side is. So I'm going to do a little bit of math. I'm going to do 30 squared plus 16 squared equals c squared, the Pythagorean theorem, a squared plus b squared equals c squared. The hypotenuse, or always the longest side, is our c. So we're going to get 900 plus 16 squared is 256. Add that together, you get 1156 equals c squared. And then what we're going to do is we're going to take the square root of both sides. So the square root of a number squared is just c, and then the square root of 1156, we type that into Desmo Scientific Calculator, and we're going to get 34. So this is 34, and since these numbers are the same, this is also 34. So we can say that IT is congruent to NG. And notice that I is the 28 degrees, and I listed it first. N is the 28 degrees, and I listed it first. So although the same lengths and the same angle measures have to be together. And then now we need to, so we've proven that 1, 2, 3 sides are the same. Now we have to prove that 1, 2, 3 angles are the same. So angle R is congruent to angle A, right? It's 90 degrees. Angle I is congruent to angle N. It's 28 degrees. And now how can I figure out what the measure of G and T are? Well, again, do a little bit of math, because I know that the three angles of a triangle, the 90 plus the 28 plus the unknown, this is my unknown, the three angles of a triangle have to equal 180. So if I subtract 90 from both sides, okay, let me just do that, we're going to get 28 plus x equals 90. So that these two angles, if one is 90, the other two have to add up to be 90. So we're going to subtract 28 from 90, and we're going to get x equals 62 degrees. So we know that angle G is congruent to angle T, and I'm just writing that it's 62 degrees. So a congruent statement is going to say that these two triangles are congruent. So I'm going to use the letters of the triangles. I'm going to say TRI, triangle TRI is congruent to triangle. Now since I said the T first, and then I went down to the R, so I started at the 62 degrees, this one's 62, and I went down to the 90. I have to do GAN. GAN. The order of the letters has to match up. So the T is 62, the R is 90, the I is 28. 62, 90, 28. It all lines up. Now the question says, is there more than one correct congruent statement? Yes, there is. I could have put ITR, right? I could have gone this way. ITR is congruent to triangle N. I started at 28, I went to 62, 28 to 62, NAG. And notice the letters line up. Notice the T goes with the G. And when I have it in, did I do this right? ITR, NGA. Good thing I made a mistake to make a point. NGA. because I was going to say, notice the T is first and it goes with the G here. The T is in the middle, the G has to be in the middle because those are the two that are 62 degrees. So the like letters have to be the same. So the question says, why? Explain why. Well, as long as you line up the letters, right? As long as corresponding angles and sides are lined up, or I should say listed in order. Okay, so that's why it could be in any order. So with the idea that the letters have to be lined up, let's see if we can finish this statement. This says that MNP, triangle MNP is congruent. This little symbol right here means congruent. Okay, but then we know that congruent means that things are the same. So MNP lines up with what? Well, sometimes it's kind of hard. So one thing I'll do is I'll look at the sizes, the lengths of the sides, and I see this is the smallest side, this is the biggest side, and then this is the medium size, right? Small, medium, large, right? Small, medium, big. And over here, this is the small, this is the medium, and this is the big. So look at M. M is between the big and the small. So I'm going to put one arc mark. M is between the big and the small. So when I come over here, U is between the M and the big and the small. And then if I go to N, to get to N, I go across the big side. So I'm starting here, I have to go across the big side. So I'm going to put 2 arc marks there. And then if I leave this one, I could have 3 arc marks. Okay. So now I see M is the one with 1 arc mark. That's going to be triangle U. Then I go to N. N is with 2 arc marks. So here we go. That's going to be W. And then V is the last one, the one with 3 arc marks. So that's how you can figure out the order. Whew, but that's a lot to prove that all 3 sides are the same and that all 3 angles are the same. So let's talk about some shortcuts. Okay, here's some shortcuts right here, triangle congruence theorems. And the shortcuts are saying that if you have 3 sides the same, see how this has 1 hash mark, 2, 2, 3, 3. So the SSS stands for side, side, side. So if you can prove that all 3 sides are the same, and when you do this, you can mark on one of them. So one side is the same, a second side is the same, and a third side is the same. I guess I could have just wrote 1, 2, 3. But if I can prove that the 3 sides of this triangle are the same to these 3 sides, then I can just prove that the 3 sides are the same, and I don't also have to prove that the 3 angles are the same. Okay? And in this one, if I show you that one side is congruent to the one side in the other triangle, and that a second side is congruent to a second side in that triangle, and the angle between them, see the angle between, then you can use side, the A stands for angle, side congruency theorem. But note, on this one, the angle must be between the 2 corresponding sides. Corresponding sides. Okay? All right? So there's a second shortcut. A third shortcut has angle, side, angle. So here we have, see how this has an angle here with 1 hash mark, an arc mark here. There's one angle the same. Here is the second angle the same. Okay? And then notice we have this side right here. Guess I'll mark it in a different color. How about yellow? This side is now congruent to that side. So again, what do you think ASA stands for? You probably already wrote it. angle, side, angle. And the thing is that this side right here, see how it's between the two angles? This side is between the two corresponding angles. And it has to be that way. All right? So here are now 3 shortcuts. So why are these shortcuts important? Because instead of showing all 6 parts, the 3 sides and the 3 angles, I can just show you the 3 sides, or side, or angle, side, angle, or angle, angle, side. Angle, angle, side. And so this one, you see I have 2 angles the same. I have another set of 2 angles the same, and then I have the side. What's different about this one? Well, notice in this problem, the side does not have to be between the 2 angles. The side does not have to be between the 2 corresponding angles. All right. And there's another one, and I want you to, let's look at this one. So you can see we have the angle the same. And then I have a side and another side. And in this one, if I were to go around and let's go back and just talk at the others, see how we have AAS, right? And I can go angle, angle, side, or angle, side, angle, or side, angle, side. Okay. If I were to walk around and do this one, would say angle, side, side, angle, side, side. Oh, that spells a bad word. We're not allowed to have bad words in math. And if I went the other way and I went side, side, angle, you can't even try to trick me and spell backwards bad words. All right? You're not allowed to have that. However, if you go around and you're looking at angle, angle, side, or angle, side, side, if you happen to spell a bad word, you're like, oh, you can't have that. However, the trick is, and you guys already know how to kind of trick getting bad words in, is if this happens to be a right angle, if that angle is a right angle, then we can say hypotenuse leg. So for this one, in a right angle, if you have a leg and the hypotenuse, see how I have the hypotenuse? It's across from the 90-degree angles. I can use the hypotenuse leg theorem. Hypotenuse leg. Okay? But notice this only works in a right triangle. I guess I'll write this out. Right triangle. Oh, how do you spell triangle? Trying to get this, okay? It only works in a right triangle. So we're going to do a couple of practice problems together so you can see. All right? I like to label everything, and you only have to label stuff on one of the triangles. So here, you see I have this hash mark right here. If it's along the edge of the triangle, that's a side. Here I have the angle marked, so that's an angle, and then here, see, this is a side with this side, an angle with this angle, and then this hash mark here matches with this hash mark. So I can see, and if I just walk around this, or go around it, I can see that this is side angle side congruency theorem. Okay, let's look at some others. All right, do you see I have, and it is nice to mark stuff with color, I have this 11 is congruent to this 11. This 8 is congruent to this 8. And then, so it didn't have to be with hash marks that time. It could have been with markings here. And the 2 angles are together. So if I write on this, we have a side, an angle, and a side. Oh, that's also side, angle, side. On the next video, we can do some more practice. But you got the basic idea. You should be able to try the rest of this page on your own.